Hello. Now see, already we have finished 2 units. Now we have started chapter number 3, that is optimization. Okay. So as we already discussed in this chapter, we have to think about only two important parameters: how to maximize profit and how to minimize loss. Okay. So you have to think about company's perspectives. Okay, company always think with for maximization of profit and minimization of loss by doing some optimization. Okay, okay, so this optimization it is having two types. One is having constraint optimization and one is having unconstrained optimization. Okay, so by applying optimization techniques, okay, you must have there may be few obstacles or you can say limitations to that particular machine, okay, related to the working of any operation. Okay, so that you can say that operation, that machine will do that operation in 10 for 10 hours per day or 6 hours per day. Okay, it depends upon that machine. Okay, capacity of that machine. By considering all these parameters, okay, we can find few limitations for particular any type of machine. Again, we also having limitations. Okay, we cannot work more than 24 hours daily. Okay, so see, okay, so main purpose point is, okay, see, whenever you are thinking about profit and loss, okay, in order to have that particular profit, daily profit, and suppose that limitation of that machine is that machine, that particular operation, it is doing for that machine it will perform that operation, say it is for 6 hours. Okay, so it takes 6 hours. Now see, that machine with that operation it will not perform more than 6 hours on that particular machine. So maximum that machine will work for that operation will work for 6 hours, so that you can have that profit, not more than this, not more than this. Now in order to have more profit, okay, so that time period it should be equal to 6 hours, because it is the limitation, it is given equal to 6 hours or less than 6 hours. By doing some optimization techniques, by having few modifications in that particular machine, you can reduce the working hours for that particular operation. So it is what it should be less than or equal to a given limit. Okay, so that machine it will work, that operation it will work for only 6 hours, exactly 6 hours or less than 6 hours. So remember this, whenever you are thinking about profit, see, whenever you are thinking about profit, then your constraint, your limitations related to that time bonding, time period, it should be less than or equal to. In order to have the profit, the limitation it should be less than or equal to. Remember, less than or equal to. So this is very important, and exactly opposite. When you are thinking about loss, okay, minimization of loss, the constraint should be greater than or equal to. Remember the constraint or the limitation, they are having inequality or the sign, it should be greater than or equal to. So you can write down somewhere, you can write down like this, say maximization is equal to, it is nothing but profit. We have to always think about maximize the profit, and if the constraint it should be less than or equal to. Write down this line. And second one, whenever we have loss, then we are always minimizing the loss. Okay, so we can write here loss, and the constraint it should be greater than or equal to. So please remember these two things. And most important, see in last lecture we have studied, say we have seen, okay, we have seen how to find the maximum profit or minimum loss, maximum profit and minimum loss. Okay, so there are two methods. One is graphical method and one is analytical method. One is graphical method and next one is analytical method. So see, graphical method we have seen again today. This lecture we can see 2 to 3 types of problem related to graphical method only, and from tomorrow we will start analytical method. Okay, analytical method. Now see, while solving this problem, graphical and analytical, again the role of constraints is very important. The role of this less than or equal to or greater than or equal to, it is very important. It is very important. Now see, again, in analytical method, we have only one, okay, analytical method. That name of that method is simplex method. Okay, simplex method. And here we have to remember only one formula. Remember only one formula, and for graphical it is not required. It is very simple. Okay, so optimization, it is, there are 2 types of optimization. One is constrained and one is unconstrained optimization. Okay, here constrained and unconstrained. Constrained optimization and say one is unconstrained optimization. So constrained optimization means what? Okay, see that problem it is having one or more than one constraint. So there are the limitations. There are limitations. So we can solve the constraint optimization by using these 2 methods, graphical method and analytical method. And next one is unconstrained optimization. Unconstrained optimization means that problem it is having no any constraint, no any limitation, no any limitation. So now see. Okay, now see, we have seen one standard form of that particular problem. I will write here. We can have like this: maximize z is equal to previous one's example sample 3x plus 2y subjected now subjected. So this is the first equation I have written here: maximize, or you can find here minimize. Okay, maximize or minimize. Okay, maximize z is equal to 3x plus 2y subjected to the constraint. Now the constraint are constraint limitation. You can say x plus y is less than or equal to 10. Next one, 3x plus 2y is again less than or equal to 20. And most important, lastly, let's check the parameters. Here x and y, these are the variables, but here you can see these are the decision variables, and the value of decision variable, it should be what? It should be 0 or always greater than 0. So this is very important. That x and y, it should be greater than or equal to 0. Greater than or equal to 0. So this problem, it is with of there are 2 constraints. So it is constraint optimization, and whenever you have only this, maximize z is equal to 3x plus 2y and x and y always greater than equal to 0. So the problem is without this constraint. So you can say it is unconstrained. Now most important, in GATE examination we can have this question: the unconstrained optimization problem can be solved using which method? Can be solved using which method? We can find one is graphical, one is simplex, and third one we can say it is NR method. Okay, NR method. So this answer it is what? NR method. Okay, NR method. This is very important. This is very important. Again, this is our syllabus. Once we finish graphical method, analytical means simplex method, then we will study the NR method. Okay, so this NR method or this unconstrained optimization will have the reference of our first chapter. That is, we have studied the equal fraction methods. We have to take that one modified formula, and we have to use to solve this unconstrained optimization. Up to this, is it fine? Hello. Just reply me. हे समजते काय सांगितलं बाळा तुम्ही? Hello. Yes. Hello. Just reply anyone fast. Don't waste time. Yes.
Yes, sir.
Now, so this is the standard format of the problem. Standard format of the problem statement. Okay, problem statement. Okay. So you can have same similar format, and you can have question. Solve this by using graphical method. Solve this by using simplex method. See, in same exam, we have simplex method is for 10 marks. 10 marks the chapter, 10 marks simplex method, and graphical method you have this graphical method for 6 or 8 marks. Okay, and 2 or 4 marks they are for the theory part. Now see, okay, let's study this format. Now first one, what is given? Maximize z is equal to 3x plus 2y. So this first line indicates, you can see it is what? Hello? What is it is called as? Objective function. Okay, objective function. So the objective function means what? It is the purpose, it is the aim. And what is our aim? We have to maximize profit. Remember this, we have to maximize profit. If I right here say MI or minimize, you can say we have to minimize the loss. No, it is not minimize the profit. Okay. So it is what minimization of loss and maximization of profit. So the first line it is called as a objective function. So this is your aim. This is our purpose. Now moving further, subjected to these two are x plus 4y. It is these are the limit constraint less than or equal to, and here it is less than or equal to. Okay. So these are what constraint. Constraint means limitations. So we have given these limitations. And lastly, x plus y always greater equal to 0. Okay, so these x and y, these are the non-zero, or say these numbers which should be 0 or positive. These are the numbers, they are not negative, because see, I will explain by giving one example. Now see, this is one type of problem. You can have this type of problem in exam for 6 or 8 marks. You can have this type of problem. Again, you can have this second unconstrained type. See this unconstrained type of problem. So we have 3. Okay, we have 3. But in some cases, see, you may have this problem and question solved by graphical method. Finish. You have same problem solved by using simplex method. Okay, simplex method. Now see, in this unconstrained optimization means you cannot have this. We have only one. Z is equal to 3x plus 2y. Z is equal to 3x plus 2y and solve. You can solve this by using unconstrained optimization, by using NR method. Now, in some cases, you have given 6 to 7 lines of theory part, 6 to 7 lines of theory part, and question is okay, from this 6 to 7 lines of the problem, you have to understand that problem, and you have to rewrite this 6 to 7 lines of problem in the same format, and this is called as a formulation of LPP. This is very important. Formulation of LPP. LPP means what? Linear programming problem. Remember, this is very important. Linear programming problem. So today we will study how to formulate the problem. Linear. It is called as a linear because it is not having any trigonometric, logarithmic, or exponential or power equation. So formulation of LPP. Today we will study how to form this LPP. Okay, how to form this LPP, and this form by observing or by understanding that these 6 to 7 lines of the problem, you have to convert the problem in this format, means standard format, maximize or minimize. Just focus here. This is important. If that problem it is having word profit, then you have to maximize it. If it is having loss, you have to minimize it. If it is with maximization, use this constraint less than or equal to. If it is with minimization, use this constraint it is greater than or equal to. Up to this, is it fine? Hello? Just reply me fast. Hello? Hello?
Yes, sir.
Now, moving further, write down one heading. Formulation of LPP. Okay, formulation of LPP. Just write down formulation of linear programming problem. Okay, So now I will provide you MCQs of chapter number 1, chapter number 2, and chapter number 3. Okay. Please go through those PDF file. Okay. Try to find the answer. I will provide you the answer. Okay. But exam we can have exam in our college. Okay. It is not actually, it is not decided by university. But I think again similar to previous semester, we have to write an exam of 30 marks. Okay, again you can upload it. Okay, it is very simple. Each and every student will get 30 out of 30. Okay, and no, there is it cannot find any problem for getting out of our mark. Now see formulation of LPP. Okay, let's take one example. Okay, I will write this example here. Also, you write here. Okay, we start with one simple example. Okay, I will write here. You will write a company. A company is producing. Okay, after this problem, I will go to more problem on WhatsApp. Just try to understand. Company is producing a type, okay, a type of just a one minute, just a minute. I will back to it. Okay, I don't the problem. The company is producing a type of products, okay, a type of product within within 40 minutes, okay, within 40 minutes, and important and requires 10 minutes, requires 10 minutes for 10 minutes for painting. Okay, 10 minutes for painting. Again, similarly, for B type product, while reading, please try to understand, while writing, try to understand. B type product requires 30 minutes for production, 30 minutes for production, and 8 minutes is given, 8 minutes for painting, 8 minutes for painting. Okay, 8 minutes for painting. Okay, so see this number, 50 minutes for production. Okay, it requires to produce a type product. It requires 40 minutes for production. Again, it requires 10 minutes for painting for A type product, and for B type product it requires 30 minutes for production and 8 minutes for what? 8 minutes for painting. So these are given what? These are the constraints. These are the limitations. Means it will take 40 minutes, not more than this, not more than. It will take less than, but not more than this. Not more than 10 minutes, not more than 30 minutes, not more than 8 minutes. Okay. Now we will see further. Now the production shop, and painting shop, production shop and painting shop are available for, okay, available for 200 minutes, 200 minutes and 3500 minutes. Okay, sorry, not 200, 2000 minutes and 3500 minutes week. Okay, per week. Okay, per week. Now, what is given? See, the production shop and painting shop, they are available for 200 minutes and 3500 minutes. Means production shop will work for 2000 minutes per week, and painting shop it will work for 3500 minutes per week. Okay. Again, what is the next one? The profit for each time, the profit for each time each time paid is rupees 15. It is now it is with rupees 15, and for type B is rupees 20. Now question is formulate LPP. Question is the formulate LPP. Okay, formulate LPP. Okay, now all of you have written this problem as reply me fast. All of you have written this problem. If yes, then again please read this problem carefully. It is very simple. You can easily formulate. Now see, okay, all of you know the standard format. I will just write here. See, you can now maximize or minimize. Maximize and minimize. Z is equal to, we don't know this. Z is equal to this. Subjected to constraint. Okay, subjected to constraint. Again we don't know. And last, we have to write x and y that is equal to 0. X and y, these are the what? These are what? Decision variables. Now see, read this problem carefully. Hello, you there? Yes, please try to understand this. Again, read this problem. Okay. A company is producing A type product within 40 minutes. Okay, so in 40 minutes, we can underline this. 40 minutes required for A type product. It is for production and requires 10 minutes for painting. 10 minutes for, underline this number. 10 minutes for painting. Okay. Again, similarly for another type of product, this B type of product requires 30 minutes for production and 8 minutes for painting. 8 minutes for painting. Okay. The production shop and painting shops are available for, underline this, 2000 minutes and 3500 minutes per week respectively. It is given per week respectively. Now, so already I have told you, if you have same type of problem, just find out whether you have to maximize profit or minimize loss. So what you have to find only two words, profit or loss in this problem statement. So what is given? It is given as a profit. Okay, it is given as a profit. So if you have to minimize profit or maximize loss, always we can maximize. We can write here maximize Z is equal to. So just we can finalize here this problem. It is with maximization of profit. If you find here loss, then you can write here minimize. Okay, minimization of loss. The profit for each type A is 15 rupees. So profit for A type product is 15 rupees and B type product is 20 rupees. Okay, B type product is 20 rupees. Okay. Now see, I have written here for each and every problem, we have to define what is meant by X and what is meant by Y. This X and Y, these are the numbers. These are the numbers. Okay, so you can write here. Okay, you can write here. Okay. What you can write, say, let X be the number of production on machine A. It is the count, it is the number. So let X be the number of production on machine A. Similarly, Y be the number of production on machine B. Number of production on machine B. Up to this, you understand this? Hello, are you getting this? Just reply me, anyone?
Yes,
Abhishek
sir.
Patil, hello. Okay, so now we have initially we have to just any type of this formation of LPP. First thing you have to define of decision variables x and y, x and y. So what is x and what is y? Or you can say instead of here you can write let y be the number of production of machine A or x be the number of machine B. So let's start. Let's be this given A type, so assign x for A. So let x be the number of production on machine A and y be the number of production on machine B. Up to this it is fine. Hello? Yes? Now see, by observing this, you can formulate one table related to the A type product and B type product. So you can write here it is A type. Okay. In bracket you can write this as a X. Here you can write B type. Okay, so we don't know numbers, we have assigned Y is the number of product of B, machine B, and here machine A. Okay, now there are how many operations are there? Tell me. Hello? How many operations are here? Yes, reply one. Anyone? Hello? Hello? How many operations are there? Kirti Patil is there. How many operations are there? How
Yes,
many
sir. Two,
operations are there? Tell me.
two operations.
Which are those operations? First,
Producing and painting.
means one is production and one is painting. So here you can write operation. Write down here one is production and one is painting. Okay, one is painting. Now just think like this. Now again read this problem. A company is producing a type of product within 40 minutes. So what is this 40 minutes? 40 minutes are required for production or painting. Hello? Huh. 40 minutes are required for production or painting. So you can under this you can write here 40. Again read this problem. Requires 10 minutes for painting. So you can write here 10 minutes. So see A type product requires 40 minutes for production, 10 minutes for painting. Now B type product. Similarly, for B type product requires 30 minutes for production. You can write here 30 minutes. You can write here 30 minutes of production for and 8 minutes for painting. So you can write here 8 minutes for painting. 8 minutes for painting. Now see why I have written production here, painting here. Why not production here and painting here? So now see cumulatively what we have given. We have given the production shop. That means per week the production shop is available for 2000 minutes. So we have done here production towards. So cumulatively what is given? Production time per week and painting time per week. Okay. So now next. This is finished. So by observing this, we can easily say A type product requires 40 minutes for painting and 10 minutes for 40 minutes for production, 10 minutes for painting. B type product requires 30 minutes for production, 8 minutes for painting. Okay, now again what is given? The production shop and painting shops are available for 2000 minutes and 3500 minutes per week. What is given? Per week say respectively. It is missing respectively. Okay. So you can write here total. Okay. Total minutes per week. You can write here total minutes per week. So for production, what is given? 2000. That means for 1 week production time is 2000 minutes. It will not cross this 2000 minutes. And pending, it will not cross 3500 minutes. Okay, 3500 minutes. Do you understand this? Hello? Do you understand this? This is very important part. Hello? Any doubt? That means we have to state all these theoretical part in only three lines, one, two, three. By observing this, you can easily say a time product 40 minutes for production, 10 minutes for painting. B time product 30 minutes for production, 8 minutes for painting. And total production minutes, so total production time is per week is 2000 minutes and painting time is 3500 minutes. Do you understand this? Hello? Just
Yes,
reply.
sir.
Okay. Now what is given? Per week, time is given in terms of week, okay, per week, but it is in minutes, it is in minutes. So now that production time, it will not cross 2000 minutes and painting time, it will not cross 3500 minutes. So it will not cross means it should be always less than or equal to less than. So these are the constraints. So my concern is you must know what is this 200, sorry, 2000 and 3500. These are the constraints. And now here it is given as a profit, it is given as a profit. So by observing this, we can formulate this problem. Now I will write here. Now see, simple in this time. Now see, here it is given as a profit. Profit means we can now maximize. Now it is as a profit is maximized. I will write here. Wait, wait. So I will take this for answer. Now, what is given? Again, it is with profit means all on. We know this problem is with maximization. This is done. Now, what is given? The profit for each type A is 15 rupees. Means 15 rupees is profit for A type product. But we don't know how many products. How many products? So we have assumed those products as a X number. X number. Okay. So X number. So how you can get total profit of product A? Tell me. Hello. How you can get profit total profit of A type of product? It is given as in each product, each type of A is profit for each type of A is 15 rupees. So we have this number as a X. So total profit for product A is, tell me. Hello.
15,
Only
15x.
15x. Okay, and for B type, you can say it is 20y. It is what? 20y. So now it is with rupees, it is with again 20 rupees. And in our problem, that format of problem, that objective function means what? It is our aim, it is our goal, or it is our purpose. What is our purpose? Our purpose is to maximize the profit, maximize the profit. So always remember, objective function, it always deals with rupees, profit or loss. Then we can start, we can write here, again it is with profit. So this is your answer. So you can write maximize z is equal to, we can use this for objective function, we can write this for as a z, or you can use any, but better to use z. Z is equal to, what is, how you can have total profit? See, number of A type product X, each A type product is for 15 rupees, say profit 15 rupees, so 15 into X, we can have 50X. Plus next one for B type product number is 1, 20 rupees for each product, so 20 into 1. So we can write here 21. 21. So this is our objective function. Okay, so initially you have to define what is x and what is y. Directly, yes, always we are using x and y. But if you have same type of problem and you have not defined these two things, what is x and what is y, and you have given correct answer, you will get 0. Because initially, examiner he doesn't know what is x and what is y. So you have to define this because some student may use here C and D, whatever, okay, as per the student preference. So always you have to define decision variables. Okay, I will give you that note how to formulate this problem. In that, your first step it should be what? You have to define decision variables. Okay, x and y. So these are the decision variables. Now, below decision variables, you have to write constraint. So what are those constraints? You can write subjected to. Subjected to means you have to maximize the profit. Again, subjected to means by using this parameters by using this constraint, we have to maximize the profit. So you can write here subjected to what is your first constraint? First constraint means this first line. Second constraint means this second line. So what I can write here? 40x. See, you can write here 40x plus 30 into 1, 30y. Now it is with maximization. For maximization, what we have to use? First, I have given two lines to write maximization. So tell me this constraint whether it is
Equal to
less than or greater than or equal to
less than.
less than. Okay, so you can write less than or equal to 2000. This one 2000. And second constraint, 10x plus 8y is less than or equal to 3500. 10x plus 8y is less than or equal to 3500. And what is last line? Tell me, this is very important. If you miss to write this line, you can lose your marks. And that is about what? Decision variable. So what you have here? What is missing? Hello?
Y greater than or equal to.
Okay, so these values of x and y, see, these are the numbers. These are the numbers and zero or positive numbers. Remember, if it is zero means what? That machine is not performing production operation. Zero. Okay. So you can write and x comma y always greater than or equal to zero. If you write this part, just you have to define what is this, what is y. Then these two things means what? These two things means what? Is a problem statement where there is only 2 to 3 lines, and then this is your actual solution. If you write this correctly, then you can write this constant correctly. Simple. 40x plus 35 is less than or equal to 2000. 10x plus 8y again less than or equal to 3500. Do you understand this? Hello? Hello?
Yes, sir.
Okay, any doubt? It is very simple. Hello? Is it simple? Hello? Hello? Okay.
No doubt.
Chalo. Akshay Bhosle is there. Akshay Bhosle is there. Do you understand this? Just reply me fast. Do you understand? Akshay?
Yes, sir.
Okay. So now see we have 10 minutes. Okay. Now this is what a formulation of LPP. Okay. I will give you these notes. Okay. Or tomorrow I will provide MCQs of 1, 2, 3 because of NSEM it is on MCQs. Now see in that MCQ one can ask, see this values of x and y always less or greater than equal to 0. Okay. This objective function is deal with what? Okay, you can have profit or loss. Okay, profit or loss. If profit which constraint, if loss which constraint, we can do this type of questions. Okay. Now see, we'll move further. We will take one graphical method problem and we will stop here. Okay. Very simple. Try to understand this. Okay. So you can use this type of problem for 6 marks. 6 marks in instant exam. Okay, instant exam. Now. Last lecture I have provided 2 problems. We have solved one and I have provided next second problem. Have you go through that problem? Hello? Have you solved that problem? No. Hello? Yes, reply me. Abhishek is there? No. Have you solved? Just please check because it is with solution. Okay, it is with solution. First, we'll take one problem. Okay, and then we'll stop. Okay. Are you ready? Hello? Yes? Pay attention here. And you have to, in graphical method, you have to draw that x and y. Okay, and you have to mark those lines on graph only. Okay, on graph only. Now, right here. Now, this problem is with minimization. Okay, in last we have seen maximization. Okay, minimize z is equal to 2x plus 3y. Z is equal to 2x plus 3y subjected to 2x plus 4y is greater than or equal to 80. And next one, 4x plus 2y, again it is greater than or equal to 100. And what is last? X and y always greater equal to 0. Okay, greater equal to 0. Okay, now see, hello. Now, what is our first step? So, you have to please try to understand this problem. It is with the objective function, it is with minimize. So, always think about loss here, and how to minimize the loss. We have this objective function z is equal to 2x plus 3y, and we have this constraint. So, there are how many constraints? Tell me, anyone? There are how many constraints? Yes? Reply fast. Anyone? Reply fast. There are how many constraints?
Two.
Hello? Two constraints. So on that x and y axis, on that graph, you have to draw how many lines? Hello?
Two.
How many lines? See, it depends upon constraint. Two constraint, two lines. Three constraint, three lines. Okay. Now, your first step, okay, first step, remove this inequality sign. Remove this inequality sign and rewrite this problem as it is. Okay. So first step, okay, you can write here. Remove this inequality sign. In inequality, you can write same. Minimize z is equal to 2x plus 3y. Again, write down same problem subjected to your first. Remove this less greater than sign. We can write 2x plus 4y equal to 80, and next one 4x plus 2y equal to 100, and write down x comma y greater than or equal to 0. You can get 1 mark. This is your first step. Now second step, we have to find. See, we have two constraints. Number these two constraints is 1 and 2. Okay, so we have to find the coordinate for first constraint and coordinate for second constraint. As we already discussed this, how to find this coordinate. Okay, you can write here. For first constraint, how you can find when x is equal to 0, what is the value of y? Tell me, when x is equal to 0, what is y? Fast. Hello? Anyone reply? What is y?
20.
When x is equal to y is equal to 20, and when y is equal to 0, what is x? X is 40. Is it? Hello? X is
25.
equal to, oh sorry. X is 40. When y is 0, what is x? It is,
40.
we are dealing with only first constant. So what is y? What is x? X is 40. Is it correct? Hello?
Yes,
Hello?
sir.
Okay. So at last we can write the coordinates are first x 40, comma 20. So we have find the coordinate for constant number 1. Go for coordinate for constant number 2. Okay. So we can write for second constant. You can easily find. Then you can know what is x, what is y. When x is equal to 0, what is y? Y is equal to 50. Then y is equal to 0, what is x? X is equal to 25. So I can write directly 25 comma 50. Okay, 25 comma 50. Now your third step, you have to show these two constraints on graph. Okay, so you can write your next step, draw the graph. Okay, draw the graph. You have to draw this graph actually on graph paper. Horizontal x, you can put here say x o x dash, and here say y o y dash. Okay, make arrows are important. Y o y dash. So first line coordinate for first constraint 40 20. So first parameter, first number, it is on x axis. So see, it is 40 20. Here it is 25 50. Again, you have to use you have to use units here. Okay, unit here. This part is very important. Unit, what you can write here. Simply we can easily mark 50 and this we can write here one. We can write here same as it is 1 mm is equal to same 1 mm. Okay. On x and y axis both, we can write both. Now see here 10, 20, 30, 40, 50. On x, what is maximum? 25 maximum. It will be 10, 20, 30, 40, 50. Up to on y, it is maximum. We can put here 10, 20, 30, 40, and last one 50. Here 10, 20, 30, 40, and 50. Now, so first constraint 40, 20. So this is one first, and here it is 20. Now, join these two lines and extend these two lines. Extend these two lines. Is it? Okay, now you have to make arrow here and write down the constraint for this. What is that constraint? It is first, we can write here 2x plus 4y is equal to 80. Is equal to 80. Now for second constraint, 25, 50. So 25 is here. Okay, circle here and 50 is here. Circle it here and you can join this and extend and extend. Okay, and extend. Okay, make arrow here. Okay, make arrow here and discuss second constant 4x plus 2y equal to 100. Now, what is next? What is next? Now, you again go to your problem statement and check whether these inequalities, these constraints are less than or greater than. Now, here constraints are what? Less or greater? Tell me, the constraints are less or greater? Hello, fast? Constraints are less or greater?
Greater.
Hello, greater. So where you can show this visible region? If it is less than, below, you can remember it is less than, so this L and below, okay, this L, okay, you can remember L. So whether if it is less than, so you have to show this visible region. Below to this line is like this, here and here. But now here the constraints are greater than, means you have to show above. You have to show above. Means these arrows are important. These arrows are important. That means the constraint that visible will be line above to this line. And here again, this and okay, this and this. Okay, so the constraint about this line means it will lie here, okay. Here also about this line means here also. Okay, so what is the common region? Okay, what is the common region? See, for this line up, for this line up. So you can show the constraints. You can show this axis line here, so that it will satisfy the condition for both the constraints. Both the constraints. Correct? Both the constraints. Here you can see this visible region and name these numbers. Say, name this one. This is A. This intersection you can see this is P and this is what C. Find the coordinates. A coordinates 50, 0. This point B, okay, you have to take an actual, and this one it is 0, is for 40, and there it is 0, 50. And if you solve this problem at actual, you can find the answer x is 20, y is 10, x is 20 and y is 10. So here it is 20 and 10. Okay, at last we have to write answer. So we have here how many points? 1, 2, 3 points. We have to find z. We can write z at A, z at B, z at C. Okay, what is the equation? Z. It is 2x plus 3y. So first point 2x, so it is 80. Okay, 80 plus 0. It is 20 and 10. 20 into 2, 40. 40 plus 30 it is 70. And last here it is 050. It is 150. Okay, we have this answer 150. But which one is correct? Tell me. Hello? Which one is correct? See, this again we have to check the objective function. The objective function is what? Minimization. So find out minimum value and this is your answer. So you can write here. You can write here. Okay. the optimal solution is at point B, and that is Z at B is equal to 70 rupees. Write down the rupees. It should be on the right 70 units, and this is your answer. All of you understand this? Hello? Hello? कळतं का काय?
Yes,
Hello?
sir.
समजते? Okay. So now tomorrow also we will see two problems on graphical method. They are having with 3 or 4 to 5 constraints. 4 to 5 constraints. Here we have checked it is 4 to constraint. It is very simple. Okay. Again, you can find this answer in calculator directly 70 or this 2010. See, solve these two equations in calculator. You can get x and y. This already before solution you can get this answer 70, but we have to just cross check by using this graphical method. Now we will stop here. Any doubt you can ask the question on WhatsApp. I will put 1 or 2 problems same. I will put concern on WhatsApp. Try to solve at home. Okay. Chalo bye. Attend join your next lecture. Chalo bye.